This is section 1-8, algebra 1, and we're going to pick up with example 3. Here we're going to analyze a graph, and what I want you to observe is that when you're talking about Hey friends, here we are in Algebra 1, Section 1A, and this is the second part to this video. So, hey, let's take a look. We're looking at example 3, and we're going to do some analyzing of graphs. So, in part A, it says the graph at the right represents the speed of a school bus traveling along its morning route. Describe what is happening in the graph. And so, we've got these little flags here that we're going to address. And so, what we have here is a graph where over time, the speed of the bus is changing. So we recognize going up to be an increase in speed. So as time elapses, there's an increase in speed. Something's happening here, something's happening here, something's happening here. And so we have this situation. So we're going to look at it, and I'm going to kind of cheat because I already have the answers filled in here. And so I already mentioned what this is. This is an increase in speed, right? So as initially the speed is increasing, so we get the bus is accelerating, right? What do you think is happening here? Now, it's not that this is not the bus stopping, right? Because this is the speed, and the speed has increased, and then it stays at the same rate. So the speed is being maintained, right? And then next we have, hopefully you realize this is a decrease in speed. So the bus is slowing down. We've got the decrease in acceleration or decrease in speed. And then over here, what does this mean? Remember, this is the speed axis, and when the speed is down here, this would mean that the bus has stopped. There's no speed going on. So you see that we've got an increase, maintaining speed, slow down, stop. Increase, yeah, you get the idea. So when we talk about describing what's happening in a graph, this is the kind of explanation we need to be able to glean simply from what the graph is showing. And notice that there's no numbers here, but we recognize what increase means and what decrease means, given the graph and the orientation of the graph. In the second part of this problem, we're going to, in part B, identify the graph that represents the altitude of a space shuttle above Earth from the moment it is launched until the moment it lands. So each of these graphs show, well, these two anyway, show an increase in altitude as time elapses, right? Here, the altitude is static, and then we have a decrease in altitude after a certain amount of time. So here we've got an increase in altitude, then it's static, it stays at the same altitude, and then it decreases. Increase, and then it stays indefinitely. So which one do you think? I'm hoping that you guys realize that it would be this first one. Let me get a colored pen. That it would be this first one, graph A. We've got an increase. The space shuttle launches. It, I don't know, does what it does, hovers around, and then it lands. So we were doing from the moment it launched until the moment it lands. So we needed to have an altitude of 0 at the end. Let's look at another example. So in this example here, example 4, we're going to draw a graph, but first let's check out the information we're going to use to draw a graph. The first thing, we're going to recognize that an electronics store is having a special sale. For every 2 DVDs you buy at the regular price of $29, you get a third free. Make a table showing the cost of buying 1 to 5 DVDs. So simply put, we're going to actually use this information to fill in the chart. So the first thing we need to know or need to honor is the fact that the number of CDs will go from 1 to 5. So we've got 1, 2, 3, 4, and 5. All right. So the next thing is the total cost. So if I buy 1, we were told that the regular price is $29 a piece. So you get it. I'd spend $29 on that. If I were to buy another one, I'd double that 29 and I'd spend $58. So if I wanted 2, I'd have to spend 58 bucks. But the cool thing is if I wanted 3, I don't have to spend any more money. It's still $58. If I want a fourth one, I've got to add 29 onto that 58 and I'd have to spend $87. If I want a fifth one, you see where this is going? I'm going to add 29 onto that 87 and I'd end up spending $116. So this will be the T-table or my chart. Sometimes I'll call it a T-table because you might say it's set up like this, but that'll be my T-table or my chart representing this relation or function. So write the data as a set of ordered pairs. That would look like this. One is associated with 29, two with 58, three with 58, four, I should put this here, four with 87, and 5 with 116. And so I'm going to put commas between these, and I'll put our curly brackets or our set brackets here. So I've written them as a set of ordered pairs. Now we're going to draw a graph that shows the relationship between the number of DVDs and the total cost. And here's our graph. Right here we can see each of the ordered pairs that we have represented here is on the graph. We counted from left to right by ones, 1, 2, 3, 4, and we counted up and down by 29, which is convenient because we know that the multiples, well, that the cost of all of the DVDs that we purchase, or CDs, whatever we're buying here, the cost is each 29. So notice that sometimes you might number the axes differently. And then we got dots. We can't really connect the dots because we don't know what it costs to buy 1.5 CDs. That's not a real thing. So this graph is what we need to have. And that's it. So in example 5, we're going to look at domain and range in like a real life or realistic situation. So here we have Rasha, and she earns $6.75 per hour, working up to 4 hours each day after school. Her weekly earnings are a function of the number of hours she works. And so what that last statement is telling us is that our independent variable will be her hours, which is usually the case. Let's see if I can get that to work. Hours, and the independent variable will be the amount of money. The dependent. I'm saying crazy stuff. Let's try it again. The independent variable is this guy, and the dependent variable is the amount of money she's going to make. So identify a reasonable domain and range. Well, we know that the domain is generally associated with the independent variable, and the range is generally represents the dependent variable. So the domain is like, what are all the possible whatever the independent variable is that we could have, right? So in this case, since we decided that the independent variable is the hours, what are all the possible hours that she can work, right? So we know she works up to 4 hours each day after school. So that's like the maximum amount. So we know that the hours, I don't know why I have curly brackets down here. We know that the hours that she's going to work has to be 4 hours per day max, and a maximum of 5 days a week because she's working after school. So we know that the domain is going to be, well, the hours are going to be from 0 to 20 hours max. That's the set. And I'd write it as H, such that H is, so the hours, the domain is all the hours, such that the hours are somewhere between 0 and 20. The range is going to be the amount of money she could make depending on this particular situation. So she can make the range, or I'm going to use M as money because that's the variable that we're talking about. I should probably use E for earnings, but whatever. She can make as little as nothing, right? Or up to $135. And am I making that up? Yeah, $135 altogether, right? So where am I getting that value? Well, I'm getting this because if she works 0 hours, 0 times 675 gives me 0. If she works 20 hours, which is her maximum, 20 times 675 is 135. And so that's how I get this idea of the range being dependent on the domain and me calculating that value. All right, so the next thing we need to do is draw a graph that shows the relationship between the number of hours Rasha works and the amount she earns each week. And that graph is here. Here we have a table, or actually a graph rather, where the x-axis refers to hours, the y-axis refers to earnings. Notice how the x-axis is conveniently numbered by 5s, and the y-axis is conveniently numbered by 20s. And so we see that we start off with, for 0 hours worked, we get 0 money, $0, and for 20 hours worked, we get somewhere up here, which is, if this is 20, this is 30, and halfway between 30 and 40 will be 35. So this is her situation graphed out. I hope that makes sense. I look forward to talking to you guys soon and hearing any questions you have. And I hope everything goes well. I'll talk to you soon. The next video should be available very soon. And then the test. So you got to email me when you're ready for me to send you your test. All right. Take good care. Bye.